Daniela. So here's a little introduction on our lab. We are creating a model with two charge tapes to show an electrical force on each of them and the gravitational force that plays a role as well. So we're going to be using a few different equations. So we have Coulomb's law, which is the electrical force that is directly proportional to the charge of the objects and inversely proportional to the distance. This really just shows that the charges either repel if they are the same charge or if they attract if they're opposite charges. We use the electric field equation, the force of gravity equation, and Newton's second law, which in this case, the two different forces that are going to be acting on the tapes is going to be the electrical force and the gravitational force, and they're always equal to 0. So in the experiment part 1 and 2, here's our procedure and our observations. So we charged the tape, we put a base tape down onto the desk, having the sticky side down, and then we stuck another piece of tape on top, and then we ripped it off quickly, and this is what charged the tape. And to determine the U tape's charge, we held two of the charged tapes near each other, and they repelled. They show that they have the same charge. That's why they repelled. And then we rubbed a pen on a person's hair to give the pen the negative charge, and then we placed a tape near it. And since it attracted, we determined that the tape had a positive charge. So in the part 3 of our experiment, we determined the U tape's charge. So we hung a piece of tape off of two different chairs at the same height. We brought a charge tape under the first tape and watched it float, and we calculated about 2 centimeters that it floated up. So some of the assumptions that we made in this part was that we treated the long tape as it was a point charge with all of the charge concentration at the center of the tape. And then we also assumed that each of the U-tapes had about the same charge and was evenly distributed along the length of the tape. So we had the calculations. Here's some of our calculations. So the length of the tape was about 0.2 meters. The mass was about 2 times 10 to the negative 4th kilograms. The distance of the tape was about 0.2 meters. And the floating that we got was 0.0002 meters. So here's our gravitational force calculation. We calculated the mass times gravity, and that's what we got. And then we calculated the charge of the tapes by finding the electrical force. So here's the coding computational model. So in this model, you can see the different objects that we have, which is particle A and B. And then we did the function of calculating gravitational force and the function of calculating charge and also the electrical field. So then we also have, this is the model which shows the different arrows. And then what if the electrons had positive charge and the protons had a negative charge? What would the charge about observations you made with the tapes on other charged objects? So the tapes would still have the same charges, so it would continue to repel each other, and it would repel the negatively charged pen. So why is it important to handle the charged tapes as little as possible, and what would happen when the charged tapes encounter your hands or other objects? The tapes will end up sticking to your hands and losing their charge since they are electron deficient. The electrons would transfer onto the tapes as electrons from objects surrounding, and it would actually attract the tape's positive net charge. There would also be a decrease in the net positive charge, and the distance that we calculated in part 3 of the experiment would actually be lower than what it actually should have been. Thank you.